We're right on the edge of one of the most incredible frontiers in robotics, giving machines a real sense of touch. But this isn't just about feeling. It's about teaching them to interact with our world with a kind of delicacy and safety that, honestly, has been pure science fiction until now.
So picture this. A robot is performing surgery on a human eye. The margin for error here is, well, it's zero. Just a tiny bit too much pressure, and we're talking about a force measured in millinewtons, which is about the weight of a single raindrop, could cause permanent blindness. And this isn't a movie. This is happening right now.
So that begs the question, right? How can a powerful metal machine possibly know the difference between grabbing a steel beam and gently touching a human retina? Well, the answer sounds simple, but in practice, it's absolutely revolutionary. You have to teach it how to feel. To really get what a huge deal this is, we first have to understand the fundamental problem with most of the robots we're used to. For decades, they've been operating with a pretty critical sense missing.
Think about a classic factory robot, right? It moves from point A to point B with perfect, repeatable precision. But if you were to stand in its way, it would have no idea you're there. It would just keep pushing. It's a machine that knows position, but it's completely blind to force. And that makes it great for working inside a cage, but dangerously clumsy anywhere near people.
And this is the total game changer. Haptic feedback. It's the technology that bridges that gap, turning a robot from a numb, positional machine into a truly adaptive partner. And it's not just one thing. It's a whole suite of technologies that all work together to create this sophisticated robotic sense of touch.
Okay, so how do you actually build a sense of touch for a machine? Well, it turns out it's a lot like our own sense of touch. It's not just one single thing, but a combination of several different inputs all working together in harmony.
You can really break it all down into these three main pillars. First, you've got force and torque sensing. That's kind of like the feeling in your wrist when you push a heavy door. Then there's tactile sensing, which is all the detailed info you get from your fingertips. And finally, you have proprioception, which is the robot's own internal body awareness.
Now, the most fascinating part here has to be this idea of artificial skin. These tactile sensors are basically arrays that can cover a robot's gripper, giving it a high-resolution map of pressure. This is what lets a robot tell the difference between a sharp edge and a flat surface, or even start to identify different textures just by touch alone. It's pretty incredible.
And proprioception, that's that almost magical sense that lets you know where all your body parts are in space without even looking. For a robot, it's about sensing the forces inside its own joints and motors. This creates a baseline, an internal awareness that's absolutely crucial for knowing when an external force is unexpected, like, bumping into something.
Okay, so having all these sensors is one thing, but that just gives you a flood of raw data, right? That's only half the battle. The real magic happens in the robot's brain, the software that translates all that sensory information into smart, intelligent action.
This brings us to a really revolutionary concept called impedance control. So instead of programming a robot to go to an exact position, you program it to react to forces in a certain way. You're literally defining its physical personality, deciding if it should feel rigid and unmoving or soft and compliant.
And this contrast really shows you the power of it. If a robot is drilling a tiny hole with micron-level accuracy, you program it to be incredibly stiff and precise. But if that same robot is then going to hand a tool to a person, you program it to be soft and yielding, making it totally safe to be around. And it can switch between these personalities in milliseconds. The robot can literally be programmed to decide how it wants to react to the physical world. This shift from just controlling position to actually controlling the interaction, that is the absolute core of modern collaborative robotics.
But what about tasks where you need both? I mean, imagine wiping a table. You need to control the position of your hand as it moves across the surface, right? But you also need to control the downward force to actually clean it. That's where something called hybrid force position control comes in. The robot's software just analyzes the task and seamlessly blends both types of control at the same time.
Now, this all sounds great in a lab, but what does it actually mean for the real world? Well, this is where things get really, really exciting. Let's look at the incredible results this technology is already delivering today.
Let's go back to that operating room for a second. Get this. Studies of surgeons using these haptic-enabled robotic systems show a staggering 40 to 60% reduction in tissue trauma. By being able to feel what the robot feels, surgeons can operate with a level of delicacy that is, well, it's just superhuman.
And this isn't just about making existing surgeries better or safer. We're talking about unlocking procedures that were physically impossible before. Haptic feedback is pushing the absolute boundaries of what can be done in medicine.
But the impact goes way beyond the OR. In a BMW assembly plant, collaborative robots are now working right alongside people. And because their haptic sensors can detect the slightest, most unexpected touch, their safety record is perfect. 0 incidents in over a year and a half of operation. 0.
And here's the kicker. You'd think all that safety would really slow things down, right? Nope. These collaborative systems are running within just 5% of the speed of a fully caged-off automated robot. It's really the best of both worlds, safety and efficiency.
So, if the results today are already this revolutionary, what's next? Well, the technology is still accelerating like crazy. So what does the future hold for robots that can actually feel?
We're looking at some truly mind-bending advances on the horizon. I mean, imagine robots with artificial tactile intelligence that can identify an object in total darkness just by touching it. Or systems that mimic our own neural pathways for even faster, more intuitive responses. We're even seeing early research into quantum sensors that could detect forces at the molecular level. It's wild.
You know, this quote really captures the whole thing perfectly. For decades, we were so focused on giving robots sight, but the next great leap, the real revolution, is in giving them a sense of touch, allowing them to interact with our unpredictable, delicate, physical world in a truly intelligent way. And that leaves us with one final thought to chew on. As these machines evolve from blind, numb tools into sensitive partners that can actually feel the world around them, it won't just be the technology that changes. It's going to be our entire relationship with it. And that is a future worth thinking about.